You are standing at the gate and they call your group. Rows 40 to 45. You shuffle down the jet bridge, step onto the plane, take 3 steps into the aisle, and then you stop. Dead stop. Somebody 4 rows ahead is wrestling a bag into the overhead bin, and the entire line behind them, including you, just waits. And you have done this 100 times. You assume it is just the way boarding is. Slow, shuffling, a little miserable, but orderly. The airline calls the back rows first, then works forward, group by group, and it feels sensible. It feels like the fair, efficient way to fill a plane. Here's the part nobody tells you. Boarding back to front in that neat, orderly sequence is one of the slowest ways to fill a plane that anyone has ever measured. Not slightly slower, close to the worst. A physicist proved it. A television show tested it on a real jet. And the punchline is almost too good. Boarding people at random, total chaos, no groups at all, is meaningfully faster than the tidy back-to-front method the airline just used on you. The order is the problem. And once you see why, you will never wait in a jet bridge the same way again. So let us slow the whole thing down and look at what actually happens when a plane fills up. Start with the shape of the problem. A plane has 1 aisle. It is a single-file corridor, barely wide enough for 1 person in their shoulder bag. Everyone who boards has to travel down that 1 aisle to reach their row. So no matter how many people are waiting at the door, the aisle only lets them through in single file, 1 body at a time. That is your bottleneck. The whole speed of boarding is set by how fast that 1 narrow corridor can clear. Now, here's the thing that actually eats the time. It is not the walking. People walk down an aisle quickly. The delay, almost all of it, is luggage. Every passenger reaches their row, stops, opens the overhead bin, hoists their bag up, shoves it in, maybe rearranges someone else's bag, then finally steps into their seat. That whole operation takes 10, 15, 20 seconds. And while 1 person does it, they are standing in the aisle, blocking every single person behind them. Nobody moves. So a plane does not fill at the speed of walking. It fills at the speed of luggage, 1 bag at a time, lifted into 1 bin, while a line of people stands frozen behind the lifter. Which means the entire game, the whole secret to fast boarding, comes down to a single question. How many people can be stowing their luggage at the same time? Think about that. If 2 people are putting bags away at opposite ends of the plane, they do not block each other at all. They stow in parallel, 2 bags going up at once. If 5 people are spread out along the aisle, all lifting bags into 5 different bins, that is 5 times the work happening at the same moment, and the aisle behind each of them is short and clears fast. Spreading the luggage out means the plane fills in parallel. But if everyone who needs to stow a bag is crammed into the same 6 feet of aisle, shoulder to shoulder, then only one of them can actually reach up and load at a time. The other 4 just stand there, waiting their turn to even get to their row. Bunched up luggage means the plane fills 1 bag at a time, in a single frustrating line. It fills in serial. Fast boarding is parallel, slow boarding is serial. That is the entire physics of it. Now look again at back to front and watch what it actually does. The gate agent calls the back rows. Everyone in rows 40 through 45 stands up, walks down the jet bridge, and pours onto the plane, all heading for the same small cluster of seats at the very back. They arrive at nearly the same time in the same narrow slice of aisle, and now a dozen people are packed into the last few rows, every one of them needing to stow a bag, but only one of them can reach a bin at a time. So they queue, shoulder to shoulder, in the tightest, most concentrated jam you could possibly design, taking turns to load luggage one by one, while the rest of the plane sits completely empty. Back to front does not spread people out. It does the exact opposite. It gathers everyone who is about to stow a bag and squeezes them into the same spot at the same moment. It takes the one thing you wanted to parallelize, luggage, and forces it to happen in a single serial line. The neat, orderly grouping is precisely what destroys the parallelism. And there is a second hidden tax, one you have definitely paid, the seat shuffle. Imagine an aisle seat passenger sits down early, then a window passenger for the same row arrives. The aisle person has to stand back up, step out into the corridor, let the window passenger squeeze past into their seat, and then sit down again. Every one of those shuffles blocks the aisle for another 10 seconds. Random boarding causes these constantly. Back to front causes plenty too. It is pure wasted time, and it stacks up row after row. So this is not just a hunch. Somebody sat down and did the math. properly. In 2008, an astrophysicist named Steffen got annoyed enough standing in a jet bridge that he went home and modeled the whole thing. He simulated every boarding method he could think of, thousands of times each, tracking the aisle, the bags, the seat shuffles, all of it. And back to front came out near the very bottom of the rankings. One of the slowest methods there is. Random boarding beat it easily because randomness naturally scatters people up and down the aisle so more of them can stow at once. And then Steffen found the method that wins. His method sounds strange until you see the logic. You board window seats first, but you also spread them out. Not all the window seats at once, but every other row alternating so that two people stowing bags are never right next to each other. They are always a couple of rows apart, which means at any moment, a whole row of people is lifting bags into bins simultaneously, none of them blocking another, the aisle behind each one short and clear. Then you interleave the next set, then the middles, then the aisles. Maximum parallel luggage and almost no seat shuffle because windows go before middles go before aisles. Every part of the process that could happen at the same time does. And then a television show put it to the test on a real airplane. MythBusters got a jet and 173 volunteers with real carry-on bags, and they ran the methods head-to-head. Back to front and rigid seat block boarding were the slowest, dragging on for around 25 minutes. Boarding at random was noticeably faster. Window middle aisle was faster still, and the Steffen method won outright, filling the plane in roughly half the time of back to front. Half. From the tedious looking method to nearly the messiest looking one, and the messy one wins in a landslide. Sit with that for a second because it is the exact opposite of what your gut says. The orderly, sequenced, everybody in their group method is the slow one. The chaotic, spread out, random looking method is fast, order lost, chaos won, and it is not a fluke or a trick. It is because randomness spreads the luggage out and order piles it up, and luggage is the whole bottleneck. The order made it worse. On purpose by design. The thing that was supposed to make it efficient is the thing that made it slow. And here's the part that lifts this out of airplanes entirely because it is the same shape as 100 other problems in your life. Anytime there is a single narrow step that everything has to pass through, one aisle, one checkout lane, one merge point on a highway, one slow function in a computer program, the speed of the whole system is set by that bottleneck. And the way you make the whole thing faster is almost never to line everyone up neatly and send them through in a tidy sequence. That just guarantees the bottleneck is busy one customer at a time. The way you make it faster is to do as much as possible in parallel, to spread the work out so that many pieces of it happen at the same moment, even if that looks messier and less organized from the outside. Neat and sequential feels efficient. It usually is not. Parallel and a little chaotic feels wasteful. It usually wins. So then the obvious question, if back to front is provably slow, and it has been proven for over a decade, and there are methods that are twice as fast, why on earth do airlines still board back to front? And the answer is the honest, slightly cynical one. It is not about speed. Boarding order is a product now. Priority boarding is something airlines sell, a perk for premium cabins and credit cards and loyalty tiers, so the early groups have to be a reward, not an optimization. A gate agent calling clean back to front groups is simple and looks fair to a tired crowd. And here's the quiet truth. An airline does not actually make much more money by boarding 2 minutes faster, but it makes real money by charging you to skip the line. The slowness is not a bug they failed to fix. It is downstream of a business that has very little reason to fix it. So the next time you are frozen in that aisle, bag on your shoulder, staring at the back of someone's head while they fight with an overhead bin, understand what you are actually inside of. You are inside a solved problem being run the slow way on purpose. It is not that boarding is inherently chaotic and slow. It is that a tidy-looking order was chosen over a messy-looking speed for reasons that have nothing to do with getting you to your seat, which means there is not much you personally can do about the method. But there's one thing you can do that genuinely helps, and it is the same lever the whole problem turns on. The bottleneck is luggage. Every bag that goes under a seat instead of into a bin is one less person freezing the aisle. Travel lighter, stow faster, and you are quietly speeding up the parallel machine for everyone behind you. But the thing I keep coming back to is bigger than airplanes. We love order. We line up, we take turns, we go back to front, we build neat sequences, and it feels responsible and efficient and fair. And so often, quietly, it is the slowest thing we could have done. The real speed was hiding in the mess the whole time, in letting many things happen at once instead of insisting they happen one at a time in a tidy row. So the next time an airline boards you back to front and you feel that familiar sigh rise up in the jet bridge, remember, a physicist proved the tidy way is the slow way, and the messy way would have you sitting down in half the time. The chaos was never the problem, the order was. If you like seeing the hidden slowness inside something that looks perfectly organized, tell me in the comments what other orderly, sensible-looking system you suspect is secretly the slow one. I have a feeling a few of them are hiding in plain sight.